Hello, I'm Parshuram and I work on creating developer tools for React and React Native. In this video, we'll set up the DevOps pipeline for React Native. First, let's bootstrap a React Native project using React Native init. We'll be using Git as our source control system. For the first commit, let's add the files from the template React Native project into Git. Here is a new repo on GitHub, and let's push the source code to this repository. Once our source code is on the cloud, let us head over to Visual Studio Mobile Center at http://mobile.azure.com. After signing in with GitHub, let's add a new app. Since React Native lets us build apps for Android and iOS, we'll create two apps on Mobile Center, one for each type. As I create apps for each of the mobile operating systems, the platform selected will be React Native. Here are the various services that Mobile Center offers, including build, testing, distribution, and other app services like authentication and cloud storage. Let's get started with setting up builds and continuous integration. We are already authenticated using GitHub, so let us pick the repository and the branch that we just pushed. When setting up iOS builds, I can also sign my apps. However, the stock React Native application that was just created is not set up with the signing information. Let's set that up before continuing. Here in Xcode, I'm going to do a couple of things. First, auto signing will be disabled, and I'll pick the correct provisioning profile. The signing section in build settings should reflect this change. Next, the build configuration is set to release, since this is the variant that we want to distribute to our testers. I am also disabling tests since there are no native tests for this project. With that, we should be all set for signing. Let us commit these changes and push them to GitHub before we get back to setting up the build process. Heading back to Mobile Center and refreshing the page shows that the last commit with signing information is picked up. We should now upload the provisioning profile and certificates that I had previously downloaded from the Apple Developer Portal. Since I would like to distribute the build to other collaborators on the project, I'm going to turn on the distribution switch. With that, the project is set up with builds that run on every commit. Setting up the Android build process is very similar. After picking up the repository and branch, we configure signing for Android. As suggested on the React Native documentation, you can use Gradle to automatically configure signing. However, I have not checked in my key store and my Gradle project is not yet configured for signing. Instead, I'm going to create a new key store and upload it here to kick off the builds. After uploading the key store and quickly checking that all my settings, including distributions, are good, let us finish the setup. Android builds will now start running every time there is a commit on the master branch of GitHub. A typical build takes anywhere between 2 to 5 minutes. Once the build is complete, we can go to the build service and look at the build status. We can see things like build logs and other build artifacts like an Android APK in case of this build. The iOS build status page is very similar and shows the Xcode log output. Since this is a React Native project, apart from downloading the IPA, you can also download the source map. Source maps can later be used during symbolication of crashes. During the build process, we had also configured distributing the builds. Let's head over to the distribution service and look at the releases. There is one release in this project. An email with instructions on how to download it is sent to everyone in the collaborators group. Let us head over to our phone and install the first release of our app. Clicking on the install button takes us to Mobile Center. Testers, clients, and other end users can authenticate with Mobile Center and download the latest version of the application that is available to them. Users belonging to different distribution groups can get different version of the application. When running the application for the first time, the developer needs to be trusted. For this, we head over to Settings and ensure that apps from the developer can run on our device. And here is the application that we published to GitHub that was built and distributed to our end users by Mobile Center. Heading over to an Android phone, the process of installing a new build is very similar. We get an email about an Android build, click on the install button, and once the app is downloaded, we can open the app and test it. Let us now head back to Mobile Center and look at some of the other services like crashes and analytics. The crashes service lets you get more information about any errors that a user might encounter. The analytics service provides useful insights into user behavior. Mobile Center provides ReactNative SDKs for both these services that can be installed using NPM. The native modules can be used using ReactNative Link. The SDKs require an app secret that can be found on the Mobile Center portal. During the setup process, the SDKs can also be configured by choosing various options at the prompts. Note that the iOS SDK uses CocoaPods internally, and there are also instructions on how to set up the iOS SDK manually if required. Once the SDKs are integrated into our project, let us open up our editor and start calling some of the APIs. Here, I'm simply using a single index.js file so that I can reuse my code for both Android and iOS. First, let's start with the Analytics SDK. We'll create a button, and clicking the button will send custom events back to Mobile Center. These events can have a name and custom properties that can help us understand user interaction better. During the setup process, I had configured the Crashes SDK to be enabled by default. In this case, let us create a couple of buttons, one to simulate a native crash and the other one to simulate a JavaScript error. The generateTestCrash method throws a native exception. In case of JavaScript, any uncaught exception crashes the application. Here, I am setting up a function with a deep stack trace to show how stack traces work in the crashes service. Let us check in all these changes and push them to GitHub. We had configured Mobile Center builds to run on every commit, and the latest check-in should have triggered a build. We can also cancel running builds and reconfigure our build setup. Once the builds are complete, we should get emails telling us that there are new releases that we should download and test. All new releases are also listed under the distribute service. Let's head over to our phones and install this new build on the iOS and Android devices. The process is exactly the same as we did last time. We already had a version of the application on our device, so we don't have to worry about permissions this time around. The second release of the application now has the buttons that we added as a part of our code. Let us send a couple of events and simulate both a native and a JavaScript crash on both devices. Heading back to Mobile Center, we should be able to see the crashes and analytics information in a couple of minutes. On the crashes dashboard, I can see the crashes and any other additional information like the percentage of devices that are affected by the crashes, the frequency of the crashes, etc. The individual crashes also show us the stack trace of the crash. In case of a React Native application, the stack trace shows us information not from the minified bundle but from the actual source code. This symbolication happens since the source maps that were generated during the build process are automatically ingested into the crash reports, helping us identify the exact reason that a crash was triggered. Custom source maps and symbols can also be uploaded. Groups of crash reports can be managed by either closing them, ignoring them, or keeping them open until a resolution for the crash has been found. On analytics, we can see information and graphs like the number of daily users, device versions that the app is running on, geographical distribution, languages, etc. All this information, including custom events, can be exported so that they can be analyzed using any business intelligence software. For the final piece of the puzzle, let's see how we can update apps instantly using Code Push. Let's install the Code Push SDK and create two apps, one for iOS and another for Android in the Code Push system. We are working on integrating Code Push with Mobile Center so that you can use the apps that you created in Mobile Center for Code Push also. Once the deployment keys have been set up, let's open up our editor and change some code. Since we will only be changing JavaScript, all the changes can be pushed instantly to users using Code Push. Clicking on the button here will call Code Push sync method that checks for updates, downloads the new code and applies it to our application. Let's also add in some code that logs the current status of the Code Push sync operation and displays them in a text box. Adding Code Push to the project has changed the native code, so we will have to use Mobile Center's distribution mechanism to deliver the app to our users. We can trigger that by pushing this change to GitHub as we have been doing. After this release has been installed by the users, any JavaScript only changes can be sent directly over Code Push. We are working on integrating Code Push into Mobile Center, and in the future, the build process will have the smarts to figure out if an app has only JavaScript changes and just needs Code Push, or if it needs a full update due to native code changes. Let us install the version of the app that has the Code Push SDK integrated. Clicking on the sync button doesn't do anything right now because we haven't released a new Code Push update. Let's make some changes to our code and release a Code Push update. Now that the bundles have been released to Code Push, we can hit sync buttons on our app and we will be able to see the apps updated in place using Code Push. And that is the DevOps workflow. Check out http://mobile.azure.com for more information. And ping me on Twitter if you have any questions.